this video is a continuation upon the mole. In the last video, we learned about what the mole is and why we use it, but in this video, we're going to learn how to use it. So the goal for this video is to learn how to convert between grams, moles, and molecules. Now in the previous video, we learned that moles provide a bridge from the molecular scale to the real-world scale, and they do so by using this relationship. Now, we can think of this relationship as a sort of roadmap that tells us if we're given one of these three items, how to convert to either of the other two. So for example, if we're given grams and we want to convert to molecules, there's no arrow that's pointing from grams directly to molecules like this. So we can't convert directly from grams to molecules. We would have to convert grams to moles, then to molecules. Likewise, there's no arrow going from molecules directly to grams. So if we want to convert molecules into grams, we first have to convert to moles. So we have to go molecules to moles to grams. But if we are given moles and asked to convert to molecules, we can do that. Likewise, if we're given moles and asked to convert to grams, we can easily do that as well. So we have to follow the roadmap pretty much exactly how it's written to do these type of conversions. So the question then becomes, well, how do we convert between these three items? So to convert something between grams and moles, we do that by using the molar mass, which if you remember was grams per mole. And we get the amount of grams by looking at the atomic mass of an element or compound, whatever the question is asking us for. Now, to convert between moles and molecules, we use Avogadro's number, which, if you remember, is 6.02 times 10 to the 23rd. Here's an example of a kind of question that you might be asked that is going to ask us to convert from one of the three items to one of the others. So this question says, calculate the mass in grams of 0.105 moles of C12H22O11. Now to help us do that, I'm going to copy our roadmap up here so we can use it to reference when we're figuring out this question. So I'm going to make this a lot smaller. Okay. So when I read questions like this, the first thing I like to do is try to figure out, just try to identify what it is that I'm given and what I'm being asked to find. So in this question here, it looks like I'm given 0.105 moles of a substance, and I'm asked to find the mass in grams of that substance. So if we look at our roadmap, I'm starting off with moles, because that's what I'm given right here, and I'm being asked to find grams, because that's what the question is asking for. So now I know which way on the roadmap I need to go. So I need to convert from moles to grams. Now how do I do that? We do that by using the molar mass, which is this grams per mole relationship. And I find the amount of grams by finding the atomic mass of what I'm being asked for. Now, what are we being asked for in this question? In this question, we're being asked to find C12H22O11. So the first step of this question is to find the atomic mass of this compound. Now you should feel pretty comfortable about finding the atomic masses from earlier on in this chapter, but just in case you're not, I'm going to go through all of the steps for this first question. So to find the atomic mass for a compound, you need to take however many atoms of an element you have and times it by the atomic mass of that element and then add everything together. So the first element we have in this compound is carbon. Now how many carbons do we have? We have 12 carbons. So we're going to take 12, and we're going to multiply 12 by the atomic mass of carbon. So if we go up here to the periodic table, we find carbon, we see that the atomic mass of carbon is 12.01. So that's what we're going to write right here, 12.01. Now we're going to add that to the next element in this compound, which is hydrogen. How many hydrogens do we have? We have 22 hydrogens. and we're going to multiply that by the atomic mass of hydrogen, which if you look at the periodic table, right here is 1.01. So 1.01. And finally, we're going to add that to oxygen. How many oxygens do we have in this compound? We have 11. And we're going to multiply that by the atomic mass of oxygen, which going up to the periodic table, we see rounded to 2 decimal places would be 16.00. Okay, so 16.00. Now, if you put all this into your calculator, you should get an answer of 342.34. Now, in the previous section, we would have just written AMU as our unit on this number, but we're not going to write AMU. Instead, we're going to write this number as grams per mole. So what we are actually saying here is that there are 342.34 grams of C12H22O11, O11 in 1 mole of C12H22O11. Now keep in mind that this is a conversion factor, so we can write it like this, grams over mole, or we could actually switch the way we have this written and put moles on the top, saying that in 1 mole of C12H22O11, there are 342.34 grams of C12H22O11. So just keep that in mind. So, now let's go back to the question. In the question, we are given 0.105 moles. First, let me say that this right here, this number was simply figuring out this part right here, what this grams per mole is. Now that we have this information, we can actually do this moles to grams conversion. So that's what I'm writing down below. So the question tells us that we have 0.105 moles of C12H22O11. And we're being asked to find grams. So in this conversion factor, am I going to want grams on the top or the bottom? I'm going to want grams on the top and moles on the bottom so that moles cancels out with what I'm given. So I want to write this exactly how we wrote it up here. So 342.34 grams of C12H22O11 in 1 mole of C12H22O11. And now what that does is that cancels out my unit. So moles of C12H22O11 cancels out with moles of C12H22O11, and I'm going to multiply these numbers straight across. And when I do that, the answer that I come up with, keeping in mind significant figures, there's 3 significant figures right here in this number, so my final answer needs to also have 3 significant figures. So my final answer should be 35.9 grams of C12H22O11. And is that what the question's asking for? Is it asking for grams? Calculate the mass in grams? Yes, it is. So that is my answer for this question. Let's try another one. Let me paste our roadmap here so we have it to reference. Okay. Now this question is asking, how many moles of ZnNO32 are in 143.50 grams of this substance? Now again, let's just take a second to figure out what are we given and what are we being asked to find. So it looks like here we're given an amount in grams. So grams is going to be our starting place. And the question is asking how many moles. So we want to convert from grams to moles, and we do that by using this molar mass relationship. Now, moles of what? Moles of ZnNO32. So, if we know to convert from grams to moles, we need to find the molar mass, which in order to find the molar mass, we need the atomic mass that means the first step is going to be to find the atomic mass of this compound right up here. So I'm not going to keep referencing the periodic table because that's probably making some of you dizzy, but I'm just going to write the steps out. So the first element we have is zinc. So how many zincs do we have? We have 1, times that by the atomic mass of zinc, which is 65.39. We're going to add that to the next element, which is nitrogen. Remember that this 2 distributes to both nitrogen and oxygen. So we don't have 1 nitrogens, we have 2 nitrogens. So 2 times the atomic mass of nitrogen, which is 14.01. And finally, we're going to add that to the last element, which is oxygen. How many oxygens do we have? We have 6 oxygens, not 3, because remember, this 2 distributes. So we have 6 oxygens times the molar mass of oxygen, which is 16.00. Now, if you put this into your calculator, the number you should come up with is 189.41. Now remember, in the previous section we would have put AMU, but in this section we're going to write it as a molar mass, so grams per mole. So there are 189.41 grams of ZnNO3 in 1 mole of ZnNO3. Okay, so again, this number right here, this answer, is just giving us this information, which is going to allow us to actually do this calculation. Okay, so now, we're given grams, and we're being asked to find moles. So we're starting off with grams. So 143.50 grams. Grams of what? Grams of ZnNO3, and we want to end up with moles. So if I have grams, in this conversion factor right here, do I want grams on the top or do I want grams on the bottom? I'm going to want grams on the bottom, right? So grams cancels out with grams. So I'm actually going to have to flip the way that we wrote this right here. So I'm going to rewrite it as 1 mole of ZnNO3, In 1 mole of this compound, there are 189.41 grams of ZnNO3. Now what that does is that cancels out our units. Grams of ZnNO3, grams of ZnNO3. Now when you divide these numbers, you should get, I'm going to go a little bit closer here so I can write it better, 0.75762 mole of ZnNO3, right? Because mole is the units that we're left with in this conversion factor. And in this number, we have 1, 2, 3, 4, 5 significant figures, so our final answer also needs to have 5 significant figures. So this is a question of how to convert grams into moles. Let's look at another practice problem. Let me paste our roadmap here. Okay, this question is asking how many molecules are in 1.0 times 10 to the negative 6 moles of CH3CH2OH. Okay, so what are we given? What are we being asked to find? So the question is asking us how many molecules. So I know I'm being asked to find molecules, but what are we given? We are given 1.0 times 10 to the negative 6 moles. So this question is giving me moles and asking me to find molecules. So in our roadmap here, we're given moles and we're asked to find molecules. Now how do we do that? We do that by using Avogadro's number. So what are we given? We are given moles. 1.0 times 10 to the negative 6 moles of CH3 CH3CH2OH. And we're being asked to find molecules. Now, if you remember from the previous video, we originally wrote Avogadro's number as a conversion factor. So we're saying in 1 mole, there are 6.02 times 10 to the 23rd molecules. So if I'm given molecules, if I'm given moles here in this question, do I want moles on the top or the bottom? I'm going to want moles on the bottom so that they cancel out. So I'm going to put Avogadro's number on the top. 6.02 times 10 to the 23rd molecules in 1 mole. So now, if you put this number into your calculator, you should get 6.02 times 10 to the 17th molecules of CH3CH2OH. Because if we look here in the question, moles cancels out with moles, and I'm left with CH3CH2OH and molecules, and that answers our question. So there are 6.02 times 10 to the 17th molecules of CH3CH2OH in 1.0 times 10 to the negative 6 moles. Okay, now let's do another question. Let me paste our roadmap here. How many nitrogen atoms are in 0.410 moles of NH3? Okay, so this question is a little bit more difficult. First, let's see what we're given. So we are given 0.410 moles of a substance. So we know this is our starting point. And we're asked to find how many nitrogen atoms. So we know we want to go to molecules, right? Because molecules, atoms, basically the same thing. So how do we do that? We do that by using Avogadro's number. But notice the question isn't asking us for NH3 atoms. It's asking us for just nitrogen atoms. So we'll take a look at how we do that. So first we need to figure out how many molecules are in the entire substance. So if we're given 0.410 moles of NH3, we first need to determine how many molecules are in NH3. So to do that, we use the Avogadro's number conversion factor. And since we are given moles and we want molecules, we're going to put mole on the bottom so that it cancels out. So on the top here, I'm going to put 6.02 times 10 to the 23rd molecules. And I'm going to put mole on the bottom. Now, if we put this into our calculator and cancel out our units, so moles cancels with moles, and what we're left with is NH3 and molecules. So if you put this into your calculator, you should get 2.46 times 10 to the 23rd, and now the units that we're left with are molecules of NH3. Now, is that what the question's asking us for? Molecules of NH3? No, it's asking us just for how many nitrogen molecules, not molecules of NH3. So not molecules of the whole thing, molecules of one part of the whole. So if we take a closer look at NH3, that in itself can be written as a conversion factor. We can say that there is one nitrogen in one NH3. And we can also say that there are 3 hydrogens to one NH3. So if we have here molecules of NH3, and we want NH3 to cancel out, which of these conversion factors are we going to use? Well, we're not interested in how many hydrogen, so we're not going to use this conversion factor, which means we're going to use this conversion factor. So we have 2.46 times 10 to the 23rd molecules of NH3. And we want the NH3 to cancel out so that we're left with just N. So to do that, we use this conversion factor pretty much exactly how it's written, because we want NH3 in the denominator. So times 1N in every 1 NH3. Actually, let me put units on this so it's a little bit clearer. So there's 1 nitrogen molecule to every 1 NH3 molecule. Okay, so now if we look at our units, molecules of NH3 cancels out with molecules of NH3, and we put this in our calculator, we will see that what we're going to be left with is just molecules of nitrogen, which is going to equal 2.46 times 10 to the 23rd molecules of nitrogen. Is that what the question is asking us for? How many nitrogen atoms or nitrogen molecules, really just the same words? Yes, that's what it's asking us for, and that's what we're left with. That question is a little bit more difficult. So let's do one more like it. Again, let's paste our roadmap here. Okay. Calculate the number of hydrogen atoms in 0.350 moles of C6H12O6. Okay, first let's see what we're given. We're given an amount of moles. So on our roadmap, we know that moles is going to be the starting place. And we're asked to find the number of hydrogen atoms. So again, we're going to go from moles to molecules, but not the amount of molecules of C6H12O6, but we want just the amount of hydrogen. So we know we're converting from moles to molecules, and to do that, we're going to use Avogadro's number. So we're going to do this in the exact same way that we did the previous question. So we are given 0.350 moles, and we want moles to cancel, so we're left with molecules. So here again, we're going to put Avogadro's number on the top and moles on the bottom. So 6.02 times 10 to the 23rd molecules in 1 mole. Now if we look at our units, moles cancels, and we're going to be left with molecules. Actually, I should have written moles of C6H12O6, because now we're left with molecules of this. Okay, so if we put this number into our calculators, we should get 2.107 times 10 to the 23rd, and that's going to be molecules. But molecules of what? Molecules of C6H12O6. Okay, so we have molecules, but we have molecules of the entire thing. And the question is asking us for molecules of just hydrogen. So again, this compound in and of itself is a conversion factor. So we can say that there are 6 carbons in one C6H12O6. We can say that there are 12 hydrogens in one C6, sorry, not 6C. C6H12O6, and there are 6 oxygens in one C6H12O6. Now what is the question asking us for? The question is asking us for hydrogen atoms. So we're not going to want this conversion factor, and we're not going to want this conversion factor, which means we're going to use this one right here. So if I rewrite the number down here, 2.107 times 10 to the 23rd molecules. Molecules of what? Molecules of C6H12O6. And we're going to use this conversion factor up here, written how it is, because we want C6H12O6 to cancel out, so that we're left with just hydrogen. So times 12 hydrogens for every one C6H12O6. Now if we look at our units, C6H12O6 cancels out with C6H12O6, and what we're left with is hydrogen molecules. So the final answer here should be 2.53 times 10 to the 24th hydrogen molecules. Now, is that what the question's asking us for? Number of hydrogen atoms, and we have figured that out right here. All of our units have canceled successfully, and so this is the amount of hydrogen molecules in this many moles of this compound. So as you can see, these type of questions can get pretty messy. There are a lot of steps to them, but if you just follow this roadmap right here, the roadmap that we went over in the first slide, you really can't go wrong. You have to go in the order that it says, and it's just a matter of finding these little pieces down here, either finding the molar mass of something or using Avogadro's number. This is a skill that as you do more practice problems like this, it's going to get easier and easier, but work through these problems in the video a couple times, that way at least you have some guidance on how to do them, and over time it should get easier.